So now that we have some theory, let's practice that. So I have three rational functions, and what we want to do first is determine if they have a horizontal asymptote or oblique. Second thing is we actually want to find that horizontal and oblique. And then in some cases we want to find if we can cross the horizontal asymptote. Again, remember, unlike vertical asymptotes, it is okay to cross them. And in the process of trying to graph them, knowing where we cross the horizontal asymptote is sometimes useful, so we'll do that. And then once we've done all this algebra, we will turn to our graphing calculator and verify that our algebra is good. All right, so let me go ahead and do A first. So let's determine who has an oblique or a horizontal asymptote. And again, that's all about the degrees. So here I have a degree 1 up in the numerator. I have a degree 1 in the denominator. So they're equal. So this means we have a horizontal asymptote. What is the horizontal asymptote? Well, you take the lead coefficient upstairs, which is -4. You take the lead coefficient which is downstairs, which is 2. And so our horizontal asymptote in the first one is at -2. So when we do eventually go graph this, when we turn to the technology, here's y equals to 2, or excuse me, -2. I'm sorry about that. Y equals -2. I expect the graph to be tapering off towards that in both directions. So that's what we know at that point in time. What about the next one? Well, upstairs we have degree 2. Downstairs we have degree 1. So the upstairs is greater than the downstairs. So we have an oblique asymptote in this case. As a matter of fact, because the degree is just 1 above, it's not only oblique, but we know it's slant, it's a line. And then last but not least, here we have a degree 3 up in the numerator. And then down in the denominator, that's multiplicity 2. So if we expanded that out, we're going to get an x squared. And then the other one's multiplicity 3. So if we expanded that out, we get an x cubed. So multiplying them together, we get a degree 5. So in this case, the numerator is less than the denominator degree-wise. So we do have a horizontal asymptote. It is the x-axis, which we know to be y equals 0. So again, graphically speaking, right, we know that our graph is basically going to go towards 0, right, along the x-axis, right, in both directions. So that's basically part A. So again, you can see how fast that is. It's in the time that it takes to take that function and enter it, we've basically evaluated 3 functions in terms of who's who in terms of horizontal and oblique. So what about part B? Find the horizontal asymptote or the oblique. Well, we've already done that. All right, so I did that for the horizontal. It's the oblique that's a little bit tougher. What we have to actually do is perform the division. And at this time, I just realized I think I've already done this one, so I apologize for that. But let's just go ahead and do it again. We're dividing by the form x minus c. c is -1. Listing my coefficients and doing my synthetic division. We get that. So this function is behaving like x minus 1 plus -3 over x plus 1. So there, right, is what our function is going to behave like. So the oblique asymptote is x minus 1. So again, if we were to graph this, like we're going to eventually do, if I graphed that line, x minus 1, the function is basically tapering off along it. It's doing whatever in between, but it's definitely at the end behavior, it's hugging or getting closer and closer to that asymptote. All right, so there's part B. Part C, for the ones that have horizontal asymptotes, so these two here, can you find if and where the graph crosses the horizontal asymptote? So when y is equal to -2, we're just basically trying to figure out, does f of x ever equal -2? Is there an input that creates that output? And so my function in this case is 4 minus 4x all over 2x plus 1 equals -2. So we essentially have to solve that equation. Then write that over 1, and what we basically have is a proportion. So 1 times that is itself, and it should be equal to -2 times 2x plus 1. And so, yeah, -2, right? And so what we have here, 4 minus 4x on this side, and -4x minus 2 on that side. When I try to solve it, if I add 4x to both sides, and maybe subtract 4 from both sides, we end up with 0 equals -6. That's not a true statement. So this does not cross that horizontal asymptote. So there's no value of x where our function actually crosses it. So the behavior, it's going to be doing something. As a matter of fact, we can see that the vertical asymptote's at -1/2. So we're either doing something like this, right, or the opposite direction, right? Let me put that in red. Or maybe we're doing something like that, right? That's what I can tell just by knowing what the vertical and the horizontal asymptotes are and whether I cross it or not. So I already have a quick sketch. Again, I'm probably even faster than the calculator, right? So here's another one where we had a situation where we crossed the x-axis, and so y is equal to 0. So we're basically trying to figure out, well, when does f of x equal to 0? So my f of x is x cubed minus 8 all over x plus 3 squared x minus 5 cubed is equal to 0. And so what ends up happening here is to find the when this is equal to 0, if we would multiply by the LCD on both sides, it would cancel out, and we're basically left with when the top equal to 0. All right, and recall what we're also doing here, big thing is we're trying to find x-intercepts, really, to tie it into another idea. So what this is kind of theoretically showing us, and I'm doing a little bit of 5.5 here, is to find my x-intercepts, I basically decide when the top's 0. But back to what we're doing, how about I add that 8 to both sides, take a cubed root, and we see that this is happening at 2. So we do actually cross this, and we're crossing the horizontal asymptote at the location 2 over 0. Alrighty, so there you have it. I'm already 6 minutes into this. We're going to turn to the technology. We're going to do part D in a moment. But just to give me some more time in case I have to explain some of stuff more, I'm going to go ahead and cut away to another video and do that, start fresh. But there's our analysis for A, B, and C. We have a horizontal asymptote, we don't cross it. We have an oblique, we found it. We have a horizontal asymptote, I found a location where we cross it. We'll go visualize this with the technology and verify that our algebra is right in a moment.